Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and this is our second video on completing the square. Let's start by linking to what we did in the last particular skill. Pause the video and try and answer the following questions. Firstly, what is completing the square? Secondly, why is it going to be useful to us? I mentioned two potential reasons. And lastly, complete the square for that quadratic expression. Okay, now completing the square was taking a quadratic expression, maybe like this, and writing it in this form, a perfect square with an adjustment that's needed. Okay, so writing it in the form brackets x add a all squared add b. Why is it going to be useful? I said it's going to help us solve complicated quadratic equations, and I also said we're going to be able to use it to draw the graphs of quadratics. So we haven't seen that yet, but just to keep in mind, it is going to be super useful, so it's a great technique to master. Lastly, how do you actually complete the square? Well, we need to write it in that form. We know it's going to have an x in the bracket and it's going to have a square outside. We know that the number in the bracket is going to be half positive 4, which is positive 2. We square this out in our head and think what we get. We should be good at doing these. X squared, add 4x, add 4. Now we didn't want an add 4 in there, so let's just take off that positive 4 so that we haven't included anything we don't need. And don't forget, you need to add in that positive 10 at the end. Tidying up and collecting these like terms at the end, negative 4 add 10 is positive 6. So here we go, x add 2 all squared add 6. So therefore in our case here, a is going to be positive 2 and b is going to be positive 6. And that was the technique. In this particular video, we're going to complete the square where we may have to rely on fractions inside our brackets, etc. So make sure you go back to your fractions work to make sure you're super good at that before going on here. Right, straight into some examples. Write the following quadratic expressions in that form. That means complete the square. Okay, what are we going to do? We know we're going to have an x in our bracket. We know we're going to have a squared there. We're going to half positive 3. Half of that, best write it as a fraction, 3 over 2. Don't write 1.5 in there, guys. Always keep it as fractions. It's much easier to work with fractions. Now, what does this give us? This will give us x squared add 3x. And it will also give us add 3 over 2 all squared. Now we should know how to do 3 over 2 all squared. I'll write it here. 3 over 2 squared means 3 over 2 multiplied by 3 over 2, which is 9 over 4. Okay, so we know from this we're going to get a positive 9 over 4. So we have to take away 3 over 2 all squared, which is 9 over 4, from our answer. Now don't forget at the end, we've got to add back this 3 here. Now we have to do a bit of tidying up. We've got to collect like terms here. Now we're going to have to add this fraction to this number here. In order to add or subtract fractions and numbers, we've got to make the denominators the same. That 3 is really 3 over 1. To make it have a 4 on the bottom, I need to multiply by 4 and multiply by 4. So this is maybe going to take us 2 lines of working. This thing stays the same. There's no work to do there. But here, we're going to have negative 9 over 4. And when we multiply that by 4, we're going to add 12 over 4. Now, negative 9 over 4 add 12 over 4 is positive 3 over 4. Or you could just think of this as written the other way around. That's 12 over 4. Take away 9 over 4, which is 3 over 4. Okay, whatever way works for you. So collecting those two terms up at the end, we're going to get ourselves x add 3 over 2 all squared add 3 over 4. And in this case, our p is 3 over 2 and our q is 3 over 4. And we're done. So you can see here there's just a little bit of extra work with fractions. You've got to be good at squaring a fraction in your head, and then you've got to be good at combining a fraction and a number. So common denominators, adding fractions and whole numbers. Right, let's have a go at this one here. That's really a negative 1, isn't it? So it's helpful to put that in. We know it's going to have an x, we know it's going to have a squared. We're going to half that number, which is negative 1. That would be negative a half. Square, what are you going to get when you do this? X squared, subtract 1x, and then you're going to get what's negative a half all squared? It's positive a quarter. You don't want a positive quarter here, so take off that a quarter, and don't forget to add that 1 that was in the original expression. Now it's quite easy to do this one in our heads. This one's actually easier. We don't have to make common denominators here. Negative a quarter, add 1. Well, you can just think of that as 1 subtract a quarter, which is 3/4, positive 3/4. So we've got positive 3/4 here. In this case, what's our p? P, because we've got a negative here, p is negative a half, and q in this case is 3/4, and we're done. Last example for you to try. Okay, we know we're going to have an x, we know we're going to have a squared there. We've got to half 2/3. So maybe go over here and think of what is 2/3 divided by 2, a half of 2/3. You can think of that as 2/3 divided by 2 over 1, which dividing by a fraction is the same as multiplying by its reciprocal. 2/3 multiplied by a half, these twos cancel here, and you're going to get yourself 1/3. You could also think of it as you have 2/3 and you half it, so you must have 1/3 when you do that. So in here I'm going to have plus 1/3, which is half of 2/3. Now you know this gives you the x squared add 2/3 x, but now you know it also gives you whatever the answer is to 1/3 all squared. 1/3 squared is 1/3 times 1/3, which is 1/9. So you need to subtract off that 1/9, and don't forget to add back the 1 that was in the expression. And again, this is quite an easy case. You have x add 1/3 all squared. Now you know this here, you could write that as 1 subtract 1/9, which is 8/9, positive 8/9. And in this case, p is going to be 1/3 and q is going to be 8/9. And we're done. And that's it for this video. Thanks for watching.